Hello, this is Mr. Craig, and today I'm going to talk about skeletal structures. So, looking at this, I know that you love to draw it out with all the hydrogens and showing all the carbons, but there is an easier way. It's called the skeletal method. So, what's the longest chain here?
9.
1, 2, 3, 4, 5, 6, 7, 8. Not bad, not bad. We're learning. So, it's 8, and if you're not sure, you can touch count. So, whenever we draw the skeletal structures, that line right there represents 2 carbons. And at the end of each line should be a carbon. So if we go ahead and continue this, there's 3, 4, 5, 6, 7, and 8. Okay? So this represents the long chain. So 1, 2, 3, 4, 5, 6, 7, 8. And then over here we have 1, 2, 3, and we have a what kind of group here? Ethyl. So at the number 3 carbon, we're going to go up and over. So that's your ethyl. And then up here, what do we have? What kind of butyl? Iso, because it's bound to one of these middle carbons. So let's see, that's on the 1, 2, 3, 4. So 1, 2, 3, 4. So we're going to go up, and it's an iso.
Is it on the 5th?
1, 2, 3, 4. Are you sure you're 1, 2, 3, 4, 5? I went this way. So it's 1, 2, 3, 4 this way, and then this is 1, 2, 3, 1, 2, 3 that way.
Doesn't matter. Do we have like a key for like what the ethyl and butyl look like?
Yeah. Ethyl's 2, methyl's 1,
Oh, right.
propyl's 3.
There's the line.
So what this does, this structure that I just drew down here represents this top. Now, the nice thing is we don't have to go through and draw the carbons and represent all of that, but technically that's what we have. So what would we have here? Carbon with how many hydrogens? 2, good. Remember, the key here is that it has 4 bonds. So what kind of carbon-hydrogen combination do we have there? Just an H, good. Okay, now that's the nice thing. We don't show hydrogens like we do here, and the carbons are your endpoint. This one, what's my longest chain? So 1, 2, 3, 4, 5, 6, good. So we'll go 1, 2, 3, 4, 5. Is that right? 1, 2, 3, 4, 5, 6. Okay, and what's the name of that longest chain? Hexane. Okay.
So if it was just that, it would just be hexane.
If it were that, it'd be normal hexane. But we have what kind of group here on the number 2 carbon? Or what kind of groups? Methyl. So we had 2 methyls. So in this case here, we're going to go like that to represent 2 methyls. Don't do this where you draw it up and down. That looks kind of strange. And again, this is implying that this is kind of representing the 109 angle with the tetrahedral shape, but we don't care about that. Getting all hung up on that. And then, so 1, 2, 3, 4. So 1, 2, 3, 4. That other methyl would look like that. So what's the name of this shape here? Two, 2. 2, 2. So 1, 2, 3, 4. So 2, 2, 4. Trimethyl hexane. Good, okay. We didn't name this top one up here. What's the name of this compound? So 1, 2, 3 versus 1, 2, 3, 4. So a 3-ethyl, 5-isobutyl, octane.
So how do you know it's isobutyl at the bottom?
So from here?
Yeah.
Because again, this represents that it's not bound to an N carbon.
Okay.
Yeah, so you'll see this is what isobutyl looks like. Isopropyl looks like a Y. Okay. All right, let's go to the cyclos. So here's, yeah.
On the one like above.
This one?
Yeah.
Okay.
What if you have like a butyl and like a propyl? Would you still make it like that one, like this?
Okay, butyl. Here, let me. Let's just make up another one here. So 1, 2, 3, 4, 5. 5. And then what do you want?
Like the butyl and the
A butyl here?
Were to the same carbon. Yeah. Like,
A butyl and a propyl?
like you see how like there's a methane on top and a methane on bottom?
Yep.
What if there's like a butyl and a propyl? They still both
So a butyl here and a propyl here. Okay, so a butyl would look like this. So 1, 2, 3, 4, and then a propyl 1, 2, 3.
So you would still draw them both down.
Yeah. Here we have, back in the day, we would draw it like this. Okay. And if we left it like that, what would that be called? Cyclohexane, yeah. If we had a ethyl group there, and let's say we had 2 methyls here, okay, what would the name of this structure be?
No, it would be one dimethane, 2.
Go with the
Methyl,
go with the
sorry.
smaller numbering.
Yeah.
So we would want it to be a 1,1 versus a 2,2. Now say that again. What was?
1,1-dimethyl 2-propyl.
Cyclohexane.
Sorry, I thought that part was
Cyclohexane.
Yeah.
Yeah. So the whole thing there. Good. Now the nice thing about this is we have our hexane. So I'm going to cheat here. So hexane is 6. So I'm cheating here. I apologize. And we want to go with a methyl, 1, 2, and what was the other one? Propyl. So 1, 2, 3. So that looks like that. That's a lot cleaner, isn't it? Now try to keep your curves going, and I had somebody do something like this earlier today. Let's just say it's a butyl, cyclobutyl. They were wanting to draw their methanes like this, or their methyl groups like that, or their propyl groups like that. Okay, technically what we want to do is we want to break up the continuity so it doesn't look like it's an extension here. So if you can, kind of change the angle if you're drawing a methyl or multiple methyl groups off of that. So if you only had one, say, on this cyclobutyl, then draw it like that. Does that make sense? Okay. Let's do one more here. So, connecting this. And let's go ahead and put a C. Now let me clarify that. Let's say that line is its own hydrogen. That's kind of ugly. And let's go CH2CH3. So to clarify this, this is connected to this middle carbon right here. Okay. So what would the name of this be?
Let's see.
Well, wait, before you do that, let's draw the skeletal shape, and then we can name it from there. Okay, so what is our cyclo? What shape do we have? An octane, good, so we'll go octane. Okay. And what do we have, say, on this carbon right here? A methyl and a ethyl. Okay, so a methyl and an ethyl. So we'll go methyl. Oh shoot! My bad.
Oh my.
Oh no! So we got a methyl and an ethyl. And what do we have on this carbon here? And again, that's trying to represent a hydrogen. This is representing an isopropyl. So that would skip one and go here. Okay. And then next to that, we have a methyl. Okay. So that shape represents that mess. True or false? True. Okay, so now that it's a little cleaner, how should we number this? Where should the numbers start? Should it start here or here?
There.
So start here, and we're going to go clockwise or counter? Counter. Good.
That's clockwise.
That'd be clockwise.
Oh wait, sorry. That's well, you indicated the wrong direction. I blame you.
Say it again. I'm sorry.
That's the apple. Ooh, you. One starts next.
Oh, we have 2 here. My bad. My bad. Forgot about that. So we'll put the 1 here. Good catch. So there's 2 groups there. So there. And yeah. So it should be a 1-1. So we should have 2 1s here. So what would the name of this be? So we have 1 ethyl. Good.
1,4 dimethyl.
1,4 dimethyl. 3 isopropyl. Cyclohexane.
Okay, sorry. That's what. I wasn't like.
Okay. So the key here is, and again, nothing wrong with counting with your finger. I mean, I do that often when I'm doing the skeletal. But the beautiful thing is, we don't have to, and this is the way we're going to draw these shapes from this point forward. And hopefully that once you get into organic chem, once you get into college, you're going to go right to this instead of going, do we have to draw all those carbons and hydrogens? Because I guarantee your organic teacher is going to go, well, if you want to, yeah, it's going to take a lot longer, but this is so much faster. So much faster, so much cleaner. This shape representing that shape here and so forth. I mean, that isn't the same thing, but it's an example. Just, it's a little easier. Questions on that? Yeah, pretty easy. And this is the type of stuff we'll have a quiz on Friday.